All right, once again, I'm one of those English speakers. A little bit tired. But just can I get a show of hands of anybody who is writing Go today? Awesome. For the rest of you, go to golang.org. Yeah, so compile time code weaving in Go is the talk name, and it really kind of gets at one of the things that I personally don't like about Go, and I'm kind of a Go fanatic. So some of the software that we write, you know, people were like, oh man, I really like your software, but I don't want to have to like put this into my code base because I want to keep my code base clean and so forth. And it really gets to what I think sucks about Go. And if you follow the Go community, packaging and vendoring is a really hot topic. But packaging in that sense is not what I don't like. It's more of the fact that the runtime reflection is so poor compared to the JVM or to Ruby or something like that. So being able to like modify third-party code bases is relatively difficult to do. And I was talking to this guy from London so many months ago, and he's like, oh, have you ever heard of Aspect J? And I was like, yes, you know, I've heard of it, and I've also heard people that you know, think it's Satan, basically. So anyway, we're talking about it, and so we're like, yeah, what about it? And is this a joke? You know, I mean, is this really something that we would use in Go? But when you think about it, you know, I'm not like a code purist. I code to get shit done. I have a job to do, and so I code. And so I don't try to get into religious debates about whether or not something's the right way to code, right? And Rob Pike, you know, one of the co-creators of Go, has this wonderful quote from earlier this year, which is our full-time job, write a program to write a program. And it really kind of gets at the heart of, you know, preprocessors specifically, which is what AOP ends up being. Enter code weaving. So Go is actually a decent fit for compile time code weaving, in my opinion. It's statically typed language, and it's compiled. So it actually fits pretty well compared to your dynamically typed languages that you can modify at runtime. We actually have prior art in this category. We have Go Fumped, Go Fix, Go Generate. At the bottom, you can kind of see a Go Fumped rename example where it renames bytes.compile a comma b to bytes equal a comma b. And this is something that Russ Cox wrote, and it's really cool, but it's a lot of code. So this is an example of Go Fix, and all this crap you have to write to like do one tiny modification on the code base. Now, if you're porting an API, this is like really helpful, but I don't want to write all this stuff. This is too much. So I'm being the traditional lazy programmer that I am. You know, it goes back to we don't want wrap, we don't want code residue in the code base, and it's a non-trivial amount of work. So what do? Well, we can't just use regex. We can't use sed. You know, some of the problems we run into is scoping. Are you inside of a function, outside of a function? Are you part of a class, not part of a class? We don't even have classes in Go. The mini packages, you know, is this package is a third-party package? And then references, you know, maybe I have a reference to this variable, and then I have the same named reference to another variable. So clearly, just doing a regex on your code base or using sed or something like that just isn't going to work. Enter aspect-oriented programming. So to go over some definitions, I'm sure some of you are familiar with this, but for those of you who aren't, we can go over some of these definitions. So an aspect really gets at the core principle, which is a cross-cutting concern. And a cross-cutting concern is basically all these places in your code base that have absolutely nothing at all to do with the business logic. So the most canonical example is logging. All these logging statements, maybe it's a part of your user class, maybe it's part of your, I don't know, billing system, maybe it's a part of something else, and you're just log, log, log. But it has absolutely nothing at all to do with your user business logic or your billing business logic or anything like that. So this is a very common example of where you might use AOP. A point cut, basically this is just an expression that details where you can apply your code modifications. And you can think of this like a regex on the AST. The AST being the abstract syntax tree of your program. And so, in the trivial example here, we have an expression where it's 2 plus, the rest of the stuff. So we can declare our code modifications to happen on any one of these nodes. And advice is basically the ad hoc code that you want to apply at that given language. So in this example, we have the trivial hello world, for Go. And then the aspect is the combination of the point cut and the advice together. And so the full aspect gives you this ability to kind of do this crazy code modification. So we can look at some sample point cuts. A call point cut is basically before, after, or wrapping around a function. And we can kind of look at the example. So if we had func blah calling some.stuff, we can apply this point cut to where after we can put in func print line before every single call to some.stuff. So if we call some.stuff 100 times in our code base, applying this one aspect, we'll apply it everywhere without error. And this is all automated. It's not manual. And we're guaranteed that this is happening. An execute is basically before or after inside the method. So the call was around the method. It's outside the method's scope. And executes with inside. So exact same example, func blah. It calls stuff. And we have stuff doing whatever. So after that, if we apply an execute, we can modify every single execute of stuff with func print line stuff. So everywhere that actually is executed, we can insert this ad hoc code. And then within is very similar. Here we have func blah. It calls slow call and fast call. And suppose we want to time these two methods, we can do a before each slow call and a before each fast call. And that way we can kind of hunt down the root cause of why this function's slow. And then we have gets and sets. And gets are exactly as you would think they are before or after getting the variable's value. Up here, x equals stuff, func print line x. And then after we do that, right before we do our func print line x, we can say before getting x. So every single place that we try to get the value of x, we can insert ad hoc code before that. And then the corollary, of course, is the set. And we declare x.stuff, and then before that we can put in the func print line before setting x. Once again, you can put whatever code you want. You can call 20 different functions. You can modify it. You can do whatever you want. Declaration is basically the same thing, except it's the difference between a set and so in this example, we declare a channel before we actually use it. And before we declare the channel, we're saying, hey, we're declaring it. So we mentioned that logging was a common use case for applying this stuff, but there's actually quite a few different use cases for aspect-oriented programming. We have monitoring. Once again, these are all behaviors that don't have anything at all to do with your core business logic. We have performance analysis, trying to hunt down slow things. We have debugging and tracing. Every time you're trying to debug a problem, why spend hours hunting down the bug when you can just immediately apply these traces all throughout your code base? Undo functionality. This is more powerful in the runtime aspect. If you have a function that kind of calls some data, and maybe you inherited a third-party code base. It's your first day on the job, and you come in and you're like, man, this code is crap. And so you just immediately start invalidating like half the code base and declaring that it's all bad. Information validation, same thing. You can kind of put in validations to ensure that the data that's being used in the function is actually correct. And behavior mutation, once again, you can access the data and say you think the data is wrong, so you can put in behavior to actually mutate it. Of course, security. Once again, say you inherited that third-party code base, and there's no authentication on lots of different spots that it should have authentication on. Well, you can write your authentication code and then immediately apply it everywhere without having to actually code anything in. And then, of course, transactions, being able to deal with all the different transactions that we deal with. So we can look at some examples. Here, this aspect is basically, so we have two parts to it. We have the point cut and we have the advice. And then this aspect, when applied to your code base, it will log every single call to I to A inside your code base. So if you make 200 I to A calls, every place that it's called, the print line string conv occurring will be put, and it will be put before string conv I to A is actually called. The format of this aspect file is still very beta-ish. As you can see, it's like half JSON, half Go. Definitely a work in progress. And this is open source, so if you have suggestions on that, feel free to put in a pull request. Next example, validation. So here we're saying every time we execute the blah method and we pass in stuff string, when we're executing it, the very first thing we're going to do is we're going to put in this validation, if stuff equals stuff, return false. So every time we call this code's going to get put in. And once again, this code's not like staying in your repository at all. This code is just something that you apply, you weave it into the binary, and so it's inside your binary, and it'll run from there. And so this is a great way of, if you're like hunting down a bug, you can just stub out methods at compile time that you really don't care about. I do this a little bit. And then here's a more complicated example where we're basically timing database query latencies. Up here, and this is composed of two aspects. One is the top one. We have a point cut where we call query row. And so if you're talking to MySQL or Postgres or something like this, this is straight out of standard lib. Every time we call query row with string, we're going to start this timer, start time, equals time.now. And then the bottom aspect says every time we call query row, after it's done, we're going to do an end time, and then we're going to log out how long that query actually took. So when you weave this aspect into your code, and you can jump into any code base, put this in to the root, and then type in go weave, this will pop up into your binary on every single call throughout that database, instantly giving you the latency for every single select query in that code base, and you didn't have to code any of it. Here's another one where we log every single time a panic happens in a Go routine. For those of you who actually use Go, you might understand why this is interesting, because the way that Go was designed was every time a Go routine, which is like a lightweight thread, is kicked off, you have to catch each individual panic or deal with it somehow, like logging it or something like that. And if not, it blows up the runtime. And so here we're just grabbing that panic and logging it before it blows up your runtime. And so if we launch like 100,000 Go routines, then we're okay. And then, so Go Weave is the program, and it's on GitHub. We also made another repository, the Loom, to store Weave files, because this kind of goes with the idea of you really shouldn't be having to code all this crap in. You should just be able to use it. And so it's got example Weave files, and then hopefully community contributions as well. And if you want to hack around on it, it's open source. It's at GitHub/DeferPanic/GoWeave, and the examples / we files you can find at the Loom. And I think, I think that's it. So, any questions?
Hello.
Yep.
On the slide, when there was measured a time wrapping SQL query, start time and end time. What about overwriting existing variables? In the code, there can be the same variables with the same name.
Yeah. So that is something that I think, just to rephrase what you're asking, you're saying, is there a potential for reusing the same variables? Yeah.
Yes.
So that potential does exist, and it's one of those things that you might do that the first couple times you use it. After a while, you kind of get used to it. We also, past couple of months, introduced a way to have references to the variables, so we know that we're not actually like shadowing those variables. If that answers your question, but yeah, the potential still totally exists.
Okay.
Yep.
Thank you. Just one maybe dumb question, but don't you think that aspects are actually bad? Well, because you can open your code base and you don't see that there is something that you added into aspects, and then when you try to figure out what actually is going on, you can see that because it's aspect code, it's somewhere else. You can't see it in your code base straight away.
So, is the question to see what the modified code looks like?
Yeah. The question is. Can you think of a bad example of using this?
A bad example?
Yeah.
Oh, there's plenty of bad examples. Yeah, no, I mean, it's AOP has been heavily abused in the past.
Yeah.
It's in fact, if there's some older JVM devs in the audience with grayer hairs than me, I mean, yeah, they're probably plotting to kill me.
Okay.
Hello, thank you for your speech. Question. If we have several aspects for one method, I have many before aspects for one execution. How I can be guaranteed that order of these aspects will be kept?
Apply
In order.
So yeah, that does work as intended right now. And basically, when we modify the AST, we reread to get the new file lines and so forth. And so every time we apply it, we kind of keep track of where the code is. And so for every new aspect that we apply, it's still operating on the AST, but it's operating on new, new line numbers and so forth.
And so how can programmer know order of this applying?
And how do you know if it's applying?
Yes, I have several aspects in different files.
Sure.
For same execution of
Sure.
function. How can I know order of calling that aspects?
Right. So right now we don't have any systems for applying aspects out of different files that depend upon each other. If you have multiple aspects that are depending on each other, they need to go in the same file. But that's that's like an implementation detail. So.
Okay, thank you.
Yep.
Hello. Thank you for your input. I have a question about debugging aspects. We have seen examples of quite simple code in aspects, but what if I write, say, 20 or 30 lines of code and I am making a mistake there? How
Right.
do I debug that?
Sure, the actual aspect itself.
Yes.
Yeah, so there is an option to kind of like put out the code, and typically when I've been working on this, I might have a particular test for that aspect to make sure that it's kind of working as intended, and that's kind of I'll look at the output that it's generating in the temp location, and then I can kind of see what's going on.
However, there are bugs visible under certain conditions.
Yep.
Maybe there are some ways to see backtrace or I don't know, to stop execution of aspect.
To stop the execution of it?
Yes, like GDB or something like that.
Yeah, I mean, I haven't made anything for that, but there's no reason why you wouldn't be able to do that. You can use GDB, and there's Delve and a couple other debuggers for Go. So you could use it just the same, because at the end of the day, the aspects are weaving the code in as a preprocessor. So the AST is done, read into a temporary file, and then it's just basically go build from there.
And the one more question, just to make sure I have understood you correct. We can bind aspect to even library method. Not only our code is modifiable.
Oh, for outside packages, you can do that. It's not as straightforward as it should be right now. Right now, it'll operate on the root directory. So if you do that, you have to actually go up a couple of directories, and then it'll recursively go down. So that's kind of one of those things where I guess there needs to be more input from people who want to use that to determine what would the best way of doing that be. Because like if I recursively go down all my different source directories, or maybe I do it in standard lib, maybe the aspect I wrote doesn't do exactly what I want it to do at that point. So that's kind of like something that I guess needs to be worked out.
Okay, thank you very much.
Yep.
Okay, thank you for presentation.